Welcome back. In this video, we're going to learn about how to name alkanes using the IUPAC nomenclature. So, on the sheet in front of me, I have drawn 3 line structural formulas for 3 different alkanes. So, important thing with alkanes is an alkane is a hydrocarbon with just carbon-carbon single bonds. We only have carbon-carbon single bonds. And you can see that in the line structural formulas because there's only just one line between the vertices in the zigzag. So with a line structural formula, remember that the carbons are represented by the ends of these zigzags. Each end of a zig and each end of a zag is a carbon atom. All right, so let's learn how to name these. When we name them, what we need to do is first look at the longest continuous chain of carbon atoms. What's the longest continuous chain of carbon atoms? So these are all pretty straightforward ones. I'm going to complicate things in a few minutes here where I'm going to add some branches. But in these ones, you just need to count how many carbons there are in this chain. So if I look at the first one, I see 1, 2, 3, 4. So I've got carbon 1, carbon 2, carbon 3, carbon 4. And the root name that we use for a 4-carbon chain is bute. The model that we use to name alkanes, and for that matter, other hydrocarbons and hydrocarbon derivatives, is we usually have some sort of prefix. We don't always have a prefix, but sometimes we do. Then we have a root, and then we follow that off with a suffix. Prefix plus the root plus the suffix. For alkanes, the suffix is always going to be ane, A-N-E. The root, we said, depends on how many carbons there are in the chain. There are 4 carbons in this chain, so the root is bute. And a prefix we would add if there's some branches or there's other things added on to the main chain. In this case, there is nothing added onto the main chain, so the name is just going to be butane. There we go. That's butane. Now, what's the molecular formula for butane? How many hydrogens do I have in here? I don't just have carbons, I've got hydrogens too. Well, I'm going to go back and look at my chain, and for every carbon atom in the chain, I need to load it up with as many hydrogens that it can take. Understanding that each carbon atom can form up to 4 single bonds, or rather it has a bonding capacity of 4. So let's take a look at carbon 1. Carbon 1 is making a bond to carbon 2, so there's 1 out of its 4 possible bonds. That means it's got 3 remaining bonds which it can bond to hydrogen atoms. So I'm just going to indicate these with red lines. I don't want you to actually draw in these red lines, and no line structural formula will have these little lines showing hydrogens, but I'm just using these to show you where the hydrogens are located. So carbon 1 is going to have 3 hydrogens. Carbon 2 has a bond to carbon 1 and a bond to carbon 3. That means it's got 2 spots left over for hydrogens, so it will have 2 hydrogens. Same thing will happen with carbon 3. And then carbon 4 is just like carbon 1, it's going to have 3 hydrogens. Now, how many hydrogens do I have in total? I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, which means that the molecular formula is C4H10. All right, let's try the next one. Prefix, root, suffix. Once again, to find the root, I need to find how many carbons there are in the chain, in the main chain. And it has to be continuous. I can't have little breaks in there. So 1, 2, 3, 4, 5. I've got 5 carbons. So that means that the root, according to the table, is going to be pent, and the suffix will be ane, A-N-E. The prefix, I don't need a prefix because there's no branches coming off. Let's just do a check here to see how many hydrogens I have. So the ones on the ends will have 3, and the ones in the middles will have 2 each. So I should have 12 hydrogens. Great, and let's just do the last one. My last one, how many carbons do I have in the chain? I have 1, 2, 3, 4, 5, 6. So that gives it the root of hex. And once again, if you haven't watched the previous video about how to model alkanes, or if you haven't looked at the Google Doc I shared with the conventions for naming, it has all those roots and suffixes in there. So please check that out as you're watching it, or even keep it open as you're doing some of this practice on your own. So for hexane, let's load it up with its hydrogens. Once again, you do not draw the hydrogens here. I'm just using this to show you how we count them and where they occur in the molecule. I should have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So my molecular formula would be C6H14. All right, so there's 3 alkanes, butane, pentane, and hexane. They all have, all got carbon-carbon backbones with a changing number of hydrogens. But if you look closely, there's a pattern to how many hydrogens there are in a alkane dependent on the number of carbons. If you look at this, 10 is 2 times 4 plus 2. For pentane, 12 is 2 times 5 plus 2. For hexane, 14 is 2 times 6 plus 2. So you're noticing that the number of hydrogens is just double the number of carbons plus 2. So this leads us to a general formula for alkanes where the number of hydrogens in the molecule is twice the number of carbons plus 2. This is a useful way for identifying an alkane just by looking at its formula. We're going to use these general formulas in a future video when we start looking at things called isomers. They're a really good thing to pay attention to, and they can really accelerate your thinking and your analysis of organic compounds. So that's why I'm showing it to you now, and I'm going to show you general formulas for alkenes and alkynes and cycloalkanes. They're going to come up quite a little bit more. All right, let's do a couple examples with branched alkanes. So these are going to be alkanes that have some branches coming off of them, some carbon-carbon branches. So we're going to do one there, and then let's do one over here. Let's add another one there. Okay. So once again, I used line structural formulas for these compounds because I find them so much easier to draw than the structural formula or the condensed structural formula. So let's figure out what to do with these branches. So the first thing we do when we name hydrocarbon is we find the longest continuous chain of carbons. This will not always be a straight line. Sometimes, because carbons can bend and carbon-carbon single bonds can twist and turn, the longest continuous chain is not always going to be a straight line. It could curve, it could bend upwards. You just need to find the longest continuous chain of carbon atoms. So in my first example, the longest continuous chain of carbon atoms Doesn't really matter in this case. I could go 1, 2, 3, 4, or I could go 1, 2, 3, 4. But now that I have a branch here, the way the direction in which I order them or number the carbons is going to matter. With branches on an alkane, I need to add numbers to my carbons because I actually have to say at which carbon in the main chain has the branch. So I'm going to show you first the wrong way to number and name this particular molecule. So first off, let's look at how many carbons we have in the chain. So I got 1, 2, 3, 4. 1, 2, 3, 4. I've got 4 carbons in the chain. So that tells me that my root is but. The suffix should be ane. So it's going to be but. I know it's going to be butane something. But now here comes the prefix. The prefix is going to be used to indicate the branch, what type of branch we have coming off of the main chain, and where you can find this branch. So it first tells us how many carbons are going to be in that branch, and then it tells us where that branch is located coming off the main chain. So this branch just has a single carbon coming off. There's 1 carbon coming off this branch. And the branch, the way I numbered it, remember, and I'm doing this incorrectly right now, I'm just going to show you the incorrect way first. I numbered this branch at carbon 3. So because it has there's 1 carbon in this branch, things that have 1 carbon in them have the root of meth. And because it's a branch, I add the suffix to the prefix. I know this is kind of confusing, of -il, methyl. So a methyl group is a 1 carbon branch coming off of the main chain. So I would call this methyl butane. But that's not enough information because I actually have to indicate where it comes off the branch. What carbon on the main branch is it attached? And the methyl group, this 1 carbon group, is attached to carbon 3. So I would write 3-methylbutane. But that's slightly incorrect because the direction in which I number the carbons in the main chain affects where these branches come, or where the numbers that these branches get. And the numbers that my branches get in my name have to be the smallest possible number, not the slowest, the smallest possible number. So the branches need to get the smallest possible number of carbon coming off the main chain. And the way I numbered it, the direction in which I numbered things, puts the branch at carbon 3. But if I number it the other way, so I start on the right-hand side and I go left, I go 1, 2, 3, 4. If I go the other way, then my branch is coming off of carbon 2. It's the same molecule, I've just changed the direction in which I'm numbering the carbons. So to call it 3-methylbutane, that's no good. Instead, it should be called 2-methylbutane. So as much as possible, the branches need to get the smallest possible number associated with them. And that will depend on how you numbered your main branch. Did you start from left to right, or did you go right to left? All right, let's look at this last example over here. Here we've got 2 branches coming off our main chain. First thing we need to do is figure out how many carbons there are in the longest continuous chain. So I'm going to start from left to right. So I'm going to go 1, 2, 3, 4, 5, 6, 7, 8. So I have 8 carbons in my chain. That gives me a root of oct. The suffix is ane because I only have carbon-carbon single bonds. So the root and suffix is octane. And now you notice that I've got branches. I've got a 1 carbon branch right here, and I've got a 2 carbon branch right there. The 1 carbon branch will get a root of meth, and because it's a branch, we call it methyl. The 2 carbon branch has 2 carbons in it, and anytime you have a 2 carbon anything, it gets the root of F, so meth but without the M. A 2 carbon branch gets F, and then I finish it with ethyl. So I have a methyl branch and an ethyl branch. The only thing I need to do now is number the carbons. I want to go left to right because that means the branches will get the smallest possible number of carbon off the main chain. If I go right to left, they're going to try it out. Going right to left, you'll get a bigger set of numbers for these branches than if you go left to right. So I'm going to start numbering them. Carbon 1 is going to be on the end. Carbon 2. Methyl group comes off of carbon 3. The ethyl group comes off carbon 4. And then I just finish it off with 5, 6, 7, 8. All right, so I've got my 2 branches, methyl and ethyl. Ethyl and methyl, so E comes before M alphabetically, so that means I'm going to write the ethyl group first in the name. So this is going to be 4-ethyl. So between the 4 and the ethyl, I put a hyphen, so that tells me I have an ethyl group at carbon 4. After the ethyl group, I write another hyphen, and I write 3-methyl octane. So there's the name, there's the IUPAC name for this organic compound. It'd be 4-ethyl 3-methyl octane. It's a mouthful. So this might seem all a little bit overwhelming at the start. I get it. I've been there before. It takes a lot of practice, it takes a lot of repetition and drawing and sketching these out, trying them out on your own. It's like learning another language. You really do need to practice it. Try to say the names out loud. The whole purpose of this rigorous naming system is so that the name communicates enough information, sufficient information that you should be able to draw the structure of the molecule just by the name itself. So the name needs to communicate enough information that the name is all you need to draw the structure. So when I look at 4-ethyl 3-methyl octane, I know that it's exactly going to be this and nothing else. There shouldn't be any sort of ambiguity left after you read the name. The name needs to communicate everything there is about that molecule. All right. That's it for this video. This one's a little bit long at 18 minutes. The next, I think maybe we might move on to alkenes in the next video unless I decide to do some more examples of naming alkanes. All right.